In trigonometry, we work often with angles that are multiples of 30, 60, 90, 45 degrees. And those are because we have those nice ratios for them. So we just talked about in the text how we could convert any angle from radians to degrees using that formula. But what I want to do now is go through some of the common conversions that you'll see. And there is a pattern, and I'll show you that in terms of how it breaks down on the circle. But these ones you'll get memorized pretty quickly just from working with them often. So in one of the investigations, you saw how, you really get 0 degrees or 360 degrees being 0 or 2 pi in terms of radians. So the first one here is going to be 0 or 2 pi. Now, I'm going to go through and do the 90 degrees, 180 degrees, and 270 degrees first. So if we're over here at 180, which is right here, that's going to be half of 2 pi, or just pi. And that's why in the conversion between degrees and radians, we use degrees over 180 equals r over pi. So 180 degrees is pi radians. Well, 90 degrees is half of 180, so that's going to be pi over 2. And then 270 degrees, which is right down here, you could think about it as 90 degrees times 3. You could think about it as right in between 180 and 360, but that's going to be 3 pi over 2. And those are what are called quadrantal angles, so they end on an axis. Okay, so now what I want to do, I'm going to skip the third row, which are the multiples of 45, and work with the 30, the 60, the 120, and all of that. So I'm going to switch colors, but let's think about 30 degrees, which is right here. So that would be taking 180 degrees, which is pi. 180 degrees divided by 6 is 30 degrees. So this right here is going to be pi over 6. And then using that same thought process for 60 degrees, 180 degrees divided by 3 is 6. So 60 degrees would be pi over 3. And then all the rest of these are really multiples. So if we take 120 degrees, that's going to be 60 degrees times 2. So this would be 2 pi over 3. 150 degrees, which is right here, would be 30 degrees times 5. So pi over 6 times 5 is 5 pi over 6. 210 degrees is 30 degrees times 7, so this would be 7 pi over 6. 240 degrees is 60 degrees times 4, so that would be 4 pi over 3. 300 degrees is 60 degrees times 5, so that would be 5 pi over 3. And then 330 degrees is 30 degrees times 11, which is 11 pi over 6. Okay, and then for the 45 degrees, and then I'll show you one more pattern that you can use. So 45 degrees is half of 90 degrees. It's 1/4 of 180 degrees. So 45 degrees is pi over 4. 135 degrees is 45 degrees times 3, so this would be 3 pi over 4. 225 degrees is 45 degrees times 5, so this would be 5 pi over 4. And then 315 degrees is 45 degrees times 7, which is 7 pi over 4. And really what you're doing is you're breaking this circle, in congruent sectors. So if we think about this as being 45 degrees, pi over 4, this would be 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and then 8 pi over 4 would bring you right back to the 2 pi. And that would work with any of the multiples that we have here. Because 30 degrees is pi over 6, one thing that is helpful for some students is if you think about 30 degrees is 1 pi over 6, and really this would be just 0 pi over 6 for 0. And then 30 times 2 is 60, so this is 2 pi over 6, which reduces to pi over 3. This is 3 pi over 6, which reduces to pi over 2. multiply it or add another 30 onto it would be 4 pi over 6, and you could keep that pattern going. And that works for any of the ones except for the 45 degrees, but they follow their own pattern as well. So in no way, do you have to memorize this, but you will get, pretty comfortable with them very soon because you'll see them show up often.